with two circles that are tangent to each other. Draw the diameter of the large circle and note that this distance between the two circles is 10. Now draw another diameter of the large circle that's perpendicular, and at these points the distance between the two circles is 18. The question is, what is the area in between the two circles? This is adapted from a problem for 14 to 16-year-olds. Pause the video if you'd like to give it a try, and when you're ready, keep watching to learn how to solve this problem. So what's the answer to this problem? Before I get to that, I actually want to solve a different problem. Let's swap the numbers 10 and 18, because this is the actual problem that was asked of 14 to 16-year-olds. How can we solve this? We'll get started by writing the letter r for the radius of the small circle. This distance will also be r, and now 2r plus 18 will equal the diameter of the large circle. This means half of that, or r plus 9, will be the large radius. So this distance will be r plus 9. That means the two circles have a distance of 9 between their centers. Now, since the large radius is r plus 9, this distance will also be r plus 9. Since the distance between the two circles is 10, that means this distance here has to be r minus 1, because r minus 1 plus 10 is equal to r plus 9. Now let's draw a radius of the small circle, and we actually have a right triangle right here. That means 9 squared plus the quantity r minus 1 squared is equal to r squared. We have a single equation in the variable r, and we can solve it. We get that r is equal to 41. Now recall that the large circle's radius is equal to r plus 9. We can solve for the shaded area as the area of the large circle minus the area of the small circle. It'll be this formula, and it simplifies, and that'll be equal to 819 pi. And that's the answer. So now, what about the original problem where the distances of 10 and 18 were swapped? Well, you could go about it exactly in the same method as we just did. Let's let r be the radius of the small circle, and then we'll calculate the distance between the centers of the two circles. In this case, it works out to be 5. We then calculate this vertical distance, and it ends up being r minus 13. So we get a right triangle, and we again use the Pythagorean theorem. We then solve for r and get that r is equal to 97 over 13. Now before you go any further, you need to think for a minute. If r is equal to 97 over 13, what is the value of r minus 13? If you work it out, it's actually going to be a negative number. And this should raise a red flag. It is absurd to have a negative length in this geometry problem. So something has gone wrong. Since all of our steps were valid, we can only conclude one thing. The correct answer is that the dimensions in this problem are actually impossible. I think it's great to have such trick problems once in a while so that students don't just apply formulas blindly and they actually think about what they're